Have you ever wondered why the water in oceans and seas is salty? Where such tremendous amount of salt has come from that such a vast expanse of water became salty? Well, today we will find an answer to those questions. Our journey today takes us back in time, over 4.5 billion years, to Earth's infancy. Picture a young planet, newly formed from the cosmic dust and gas of a solar nebula. This was a time before the oceans, when the surface of our planet was a vast expanse of molten rock, glowing red and orange under a heavy atmosphere thick with volcanic gases. The Earth was indeed hot, its surface roiling with volcanic activity. The heat was not just residual from its violent formation, but also from the decay of radioactive elements within. This primordial heat, along with frequent collisions with other celestial bodies, kept the planet in a state of fiery flux. As the millennia passed, the surface began to cool, allowing the formation of a solid crust. Steam, released from cooling rock, rose into the atmosphere and condensed, falling back to the surface as rain. This rain was no ordinary water. It was slightly acidic, having absorbed carbon dioxide from the air. As it fell upon the land, it began to weather the rocks, breaking them down into ions that were carried by rivers to the basins that would become our oceans. Among these ions were sodium and chloride, which accumulated over time, giving the ocean its salty taste. You might ask yourself, if a rainwater is so acidic that it can break down rocks, then why isn't it dissolving everything else around us? And if the salt is being transported to the oceans and seas by rivers, then why aren't they salty? Well, let's start with rain and rocks. Envision rain as a gentle but persistent force, each drop laced with a hint of acid. Not enough to harm the flora and fauna, but sufficient to engage with the core components of rocks, their minerals. It all boils down to chemistry. The slight acidity of rainwater, caused by dissolved carbon dioxide creating a weak carbonic acid, is perfectly calibrated to interact with certain minerals found in rocks, especially those like limestone and chalk that are prone to dissolution. As time passes, this interaction gradually breaks down rocks into ions such as calcium, magnesium, and bicarbonate. These ions are then swept away by rivers to the oceans, subtly contributing to their salinity. But why aren't the softer, seemingly more delicate flora and fauna dissolved? It's because living organisms have protective measures. They are resilient and can repair, grow, and adapt. Their tissues are not composed of minerals that dissolve easily like those in rocks. Moreover, the soil acts as a buffer, neutralizing the rain's acidity. So, while the rain reshapes the rigid, it nurtures the living, each drop a carrier of life, not destruction. As for the river's saltiness, the answer is this. They are not salty because they are constantly refreshed. New rainwater, pure and crisp, dilutes any saltiness, keeping rivers fresh and clear as they journey to the ocean's embrace. Lakes too hold their secrets. Lakes are often fed by rivers of fresh rainwater, which balances and replenishes, preventing the buildup of salt. And where rivers flow out, they carry away bits of salt, leaving the lake serene and unsalted. But the story of our ocean's salinity is not just one of erosion. It is also a tale of the Earth's inner workings. Beneath the ocean floor, the tectonic plates of our planet drift apart, creating hydrothermal vents that spew hot mineral-rich water, adding to the salinity. But why is this water so hot and full of minerals? When the cold ocean water descends, it meets the intense heat from the Earth's core, which heats the water to a temperature of more than 400 degrees Celsius or 750 degrees Fahrenheit. Under such extreme conditions, water becomes a solvent, leaching minerals from the surrounding rocks. These minerals, including sulfur, copper, zinc, and even gold, dissolve in the water to create a cocktail of elements. As the mineral-laden water gushes from the vents, it mixes with the near-freezing seawater. This meeting of opposites triggers rapid chemical reactions, precipitating minerals and adding a dash of salt to the ocean's recipe. These vents are not just creators of the ocean's salinity, they are cradles of life. In the shadows of these underwater chimneys, life thrives in forms most bizarre. Creatures here are sustained not by the sun, but by the Earth's generosity as they harness the chemical energy spewing from the vents. It's a world where the rules of life are rewritten, showing us that life indeed finds a way. These processes, working over millions of years, have created the saline oceans we have today. The ocean's salinity is a record of Earth's geological and hydrological history. So when you taste a salty ocean or sea, who knows, maybe the salt that is in your mouth was pulled out from some rock a million years ago, or was born at the deepest point of the ocean and made a long journey to meet you. Thank you for joining us on this enlightening journey. If you've enjoyed this voyage of discovery, please give this video a thumbs up and subscribe to our channel for more insights into the secrets of our existence.